And the next speaker, Damian Mazurek, tells us about the journey to the legendary cloud-native standard. Please.
Hello. Hi. Thank you. Okay. Today we're going to talk about the legendary cloud-native standard, the journey that one of our customers take to migrate their systems to the cloud native. At the beginning, a couple of disclaimers. So first, I'm a little bit sick today, so you can hear different noises, some coughing, etc. But you know, I plug in many chemical things into my body to keep me running for this session. So forgive me for any different noises. But I hope that you will enjoy it as well. Okay, couple words about me. I am the CTO and the co-founder of Chmurowisko. Our international name is a Cloud State, which is the part of the SoftwareMind group. And for the last 5 years, our company helped many different customers to go to the cloud. I also am a lecturer on the universities, on the 2 biggest technical universities in Poland. I will not name them, but well, you can guess. Okay, so let's start. Today we're going to talk about public clouds and main 3, AWS, Microsoft Azure, and Google Cloud Platform. So for the beginning, I have a question to you. So how many of you already are using a public cloud? Please raise hand. Okay, that's good. That's really good. Okay, and now let's play a little bit of the cloud wars. So who is using AWS? Okay, very good representation. Google Cloud Platform? Wow, pretty well. Well, on most cases, the Google Cloud Platform is the minority, so good job. And Microsoft Azure? Wow, still a lot of people. Okay, that's great. Before, this conference, I was thinking about this cloud, public cloud. This is the Java conference. This is my first time on the Java conference, by the way. And I was a little bit, I don't know, stressed out, confused that this will not be an attractive topic for you. So, I came to my hotel, and I'm from Warsaw, so I need a place to live here. And I open my room, put my stuff away, and I go to the bathroom and I see this. And then I knew that this will be a good presentation. So, okay, let's be a little bit more serious and let's ask the question, why do you need a cloud as a Java developer? And this is the slide, like on all big conferences where there's a lot of statistics, etc. So let's go through it. First of all, the public cloud services. So the spendings on the cloud are bigger and bigger. At this moment, well, the Gartner says that there are something about $480 billion spent for public cloud in 2022. That's a 21.7% of increase from 2021. 100 zettabytes of data will be stored in the cloud by 2025. 90% of the large enterprise have adopted multi-cloud infrastructure. 48% of technology companies invest in the cloud computing innovations. And 50% of the world corporate data is on the cloud. And as you know, there is the law of the data gravity. So wherever our data, the system and the applications will go there also. So data in the cloud stimulates the cloud migration. And another very, very important thing is that, for example, cloud, especially, well, in this case, Google Cloud Platform, but the other vendors also, declared that almost 100% of the energy that they used are from the renewable sources. And for Google Cloud Platform, well, that was true for many years until they create a region and the data center in Poland, and then that's changed. But now they also claim that 100% of the energy is from these renewable sources, so let's believe them. And why this is important? Because, as you know, at the moment we have the energetic crisis in Europe, especially. We have the war, we have the gas problems, higher prices of the electricity. And from the cloud perspective, this whole situation started from the COVID pandemic, increase the adoption of the public cloud. So many organizations are considering cloud as their main, or let's call it second data center, because of all of what happened. So because of easy remote access to the resources, because of the ability to very easily move the resources from one region to another, where there will be any kind of the war, let's call it issue, inside our country or our region. And also now, the energy prices, they're also increasing the speed of public cloud adoption. Okay, sorry. And all of those reasons create one very specific thing, that the most of the new projects are born in the cloud, are created in the cloud. There was also some statistics by Gartner, if I remember correctly, that said that 84% of the new project is created inside the cloud, but I couldn't find it before this presentation, so you have to believe me on my word. And this is very important, because the software market, especially software as a service, so the SaaS market, also grew up. So many companies who develop new solutions, they are starting to develop it in this software as a service approach. And because of this, the whole software development market is very strongly directed to the cloud. But, and this is very important thing, for working with the cloud, you have to know the cloud. And the application that you build for a public cloud has to be optimized for them. And a couple of examples at the beginning. So one of our customers, which was international company, that, well, they monitor the how it's called, vehicles inside the factories and some kind of the storages. And they collect a lot of the data, for example. And they create this data pipeline based on the Google Cloud Platform. And it was written in Java, of course, using the Apache Beam SDK. And those data were collected inside the cloud storage. And the problem was that not many people know at the beginning that cloud storage is very specific, because you pay not only for the storage usage, but also for the operations. And in one point of time, they create this pipeline that was run on the Google data flow and save the data to the files for the batch processing. And the problem was that they saved every single data entity inside these files. So after 2 or 3 months, where their product go to the production stage, the cost of the cloud was horrible. So they came to us for help. And when we, let's call it, check the infrastructure, it appeared that 60% of the cost was the cost of the operation of the storage. Why? Because software developers that create these pipelines, created this code, do not know that they pay for the operation of the cloud storage. And this is a very important lesson, because now in the cloud world, every one of us need to know a cloud. And there is a very specific, let's call it knowledge distribution framework or model inside the cloud. It's called the T model. So the top part of the letter T means that every one of us and everyone in an organization should have the basic knowledge of the cloud, which services use, how we pay for them, in which scenario, how we need to modify our system architecture to have the biggest benefits of our cloud model. And this second part of the T letter, which is our deep dive specialization. And only in this model, we can work with the cloud correctly without any big risks. And today, we're gonna talk about this. So as, oops, sorry, something. So as every good story, once upon a time, there was a big financial organization. One question for you. Is anyone here from the financial organizations, especially in the Polish market? Raise your hand. Ah, there is a representation. So I understand that you know what I'm talking about. The financial institutions are very regulated. They have extremely high, especially security standards. They are also regulated by the law. And when we are talking about the cloud and the financial sector, well, it's not easy, believe me. Yeah, exactly. So in this, let's call it financial organization, well, let's call it, it was a bank. Then there was, you know, many big servers with monolithic applications, which were created a long time ago, huge Oracle databases where nobody knows who was writing or reading the data from it and how. And there was a lot of legacy systems, starting from the mainframe and ending on the, it's called the system created a couple of years ago. And the problem was that people who knew them were already retired or in other companies. So also there was small knowledge about how this whole application ecosystem works. And, you know, you can, for example, laugh at this, but this is a reality that is in extremely large number of the companies. Not even from the financial sector, but this is how it is. Well, you know, everyone has its own product roadmap, many different tasks, etc., etc. People rotated from company to company, and somehow this is our reality. But one of the biggest problems was that the developers who need to create new functionality, new business functionality, new service, new application, have to wait almost 2 months for the environments to do their work. And because of this, the whole, let's call it, time to market in this organization was about something about 3 months plus. So, for example, if you need to create a new easy feature that, for example, your team will develop it in 5 hours, you need to wait 3 months before this feature will go to the production, and you will have the real feedback. And as in every story, the hero was born. And our new hero was the new IT director, which was hired by this institution, who think that public cloud will be the solution, and the public cloud was his shield. And he started to, let's call it, I call it evangelized other people that you can use cloud. You can try to solve this problem using public cloud. Okay, and now a second disclaimer for today. So remember, this is only the presentation. So sometimes after the presentation, someone write me that he tried to use some of the stuff and create a cloud solution in their company. And believe me, after the 45 minutes presentation, if you do this in your organization, there will be a consequence for that. Because this is only 45 minutes. So I want you to think about it like the technological inspiration, because the process I will talk about took something about 2.5 years. And it is impossible to transfer the knowledge of 2.5 year experience and building practices inside the 45 minutes. So my main task for today is to inspire you and to show you the way which you can learn and discover by yourself after this presentation. Okay, let's go. So, oops, sorry, something done. So, let's start for the question, why the cloud? And this is a very good question, because whoever you will ask, the CTO, CIO, or even the students, because yesterday I have my lecture on one of the Krakow universities, and I asked my students the same question. Most of the people always finds out the same answer to this question. First one is the lower cost. So many people think that, I don't know how to say it, but that the cloud is some kind of the magical place that where you deploy your resources, your all problems will gone, and this is not true. And many people, especially based on the marketing agenda of the cloud providers, think that the cloud is cheaper. And as a good consultant, I will say yes and no, but it depends. And it depends on one specific thing, how our applications are built and how we're going to use them inside the cloud. Another thing is unlimited scalability. Here, many people also think that, you know, we have our application, it has some performance issue, but we put it to the cloud, we just switch one, I don't know, pointer, and we will increase the resources, our application will work very well. And this is also not true, because for do this, for increase the scalability of our application needs to have some standardization and some principles that will allow us to do this. Another thing is faster development. Same story. If we want to increase the development speed and time to market for our, let's call it application products, we also need to create them in very, very specific way. Another thing, reliability. Same story. Access to advanced technology. And this is the good one, because sometimes, for example, clients think, okay, so in our company, we need, for example, a real case scenario, the OCR systems. So one of our clients, well, this was the same clients that we were speaking before, said that in cloud we have something that's called cognitive services. So those are the machine learning models that are already trained on some set of the data, then you can use as a service without training. And they can do many different operations, starting from the image recognition, speech recognition, ending at the anomaly detection, I don't know, classifications, etc., form recognitions, and many, many others. So the problem was that this customer creates some models in this cognitive model approach in the cloud and connect their system to it, to OCR the documents. And it's really good because, yes, they don't have to create this by their own, and it was very cheap, but the problem was that the approach that you will just create a couple simple services inside the cloud, put there your code and data, whatever, and run it, it's good when you are a small company, small startup with 2 persons and one application combined with one web application, the small database. In every other aspect, in every other scenario, you need to have some standardization, which is called cloud governance, landing zone, and some cloud-native application standards. Okay, Go replication, the same, but let's go further, because of the time. So in cloud, we have a different model. So there's IaaS, PaaS, and SaaS. And wherever we want to use these cloud benefits, we need to increase the, let's call it, model of maturity of our application. And the more we use PaaS or SaaS, the less expensive is our product, the better scalability it has, etc. In theory, but we will address it a little bit later. But the problem is that, for example, we are creating some kind of the vendor locking. Because when you are using this public cloud specific services, then you have to use their APIs, which are very, let's call it, unique for the specific services. You need to store the data in a very specific way. You need to run your application in a very specific way. You need to collect, for example, telemetry, logs, etc., etc., etc. And whenever you want to use the benefits of the cloud, you are risking this vendor locking. And many of the cloud consultants will say that, yeah, okay, but you know, this is the two-way trade. You want to do something, you need to, for example, risk this vendor locking. But if it is true, well, on 17th of December 2021, one of our customers wrote us this kind of the message. Are here any not Polish speaker? So I can translate it. Okay. Okay, so our customer sent us the message, hi guys, I'm giving you a sign that our concept of the cloud native approach and putting our, and here's the name of the system, inside the containerization environment help us to migrate our system to the Google Cloud Platform. And the trick was that they create their system in the Microsoft Azure. And in only a couple of the hours, on the infrastructure automatization level, they migrate the whole SaaS solution for the financial market, which is very tough in Poland, and everything works. And here goes one very magic standard, which is called cloud native. And what is the cloud native? This is our basic question, because many people differently understood this concept. So I asked my friend, which I speak a lot when I feel lonely, who's called Da Vinci, and it is the GPT-3 model created by OpenAI. And I asked him, hi Da Vinci, what is cloud native standard? And he said that this is a software application that is designed to run in the cloud. Cloud native applications are typically built with using microservices, which are small independent services that can be deployed and scaled independently. And, you know, in the very high level, this is true. And many people think that cloud native application is something like this. But you know, this, let's call it modern day Gen Z AIs. They think they knew everything. So I use my other superpower and use Google search. And I try to search any of, let's call it, research about cloud native. And why? Because many people starting thinking about cloud native from this, let's use containers, let's create a small microservices, put it there, run in the cloud, everything will be fine. And this is not true, because cloud native concept is much more complicated than you think. And now I will try to prove it to you. Okay, so our researcher tried to, let's call it, index all of the research papers and the articles about cloud native from the last 10 years. And they tried to find some specific features that can truly describe cloud native standards and the things that you need to do to run your application in the cloud efficiently. And they discovered, well, a couple of the, let's call it, features that are used in most of the research papers. And they separate it on the different categories. First one is the cloud native principles, which are the principles for the platform on which the cloud native application will work. And the main of them are automation platform, migration, softwareization, interoperability, and we talk about it a little bit later. Next is cloud native architecture, and this is the architecture of the application. So we have to cloud native design there, microservices, service composition, deployment units, etc. And cloud native methods, which are some patterns, design methodology, and the DevOps approach. And only then, when we combine these three different, let's call it areas, three different words, we can create the cloud native application. And, there's also cloud native properties, like scalability, resilience, elasticity, CAP properties, and SLA. So based on it, our researchers create the definition of the cloud native application. And it looks something like this. The cloud native application is a distributed, elastic, and horizontal scalable system composed of micro or services which isolate states in a minimum stateful components. The application and each self-contained deployment unit of that application is designed according to the cloud-focused design patterns and operate on self-service elastic platform. And this is a really good definition, but really, what is cloud native? What does it mean? So if we can imagine our cloud native application as a cake, then we will have three levels of this cake. First one is the cloud platform. The main level, the biggest one, the platform on top of which our application would work. Then we have our self-service elastic platform. Well, in modern days, in the most cases scenario, this is the Kubernetes platform and the managed Kubernetes inside the specific cloud. And on top of that, we have our app itself. And to address this, let's call it cake architecture of the cloud native solutions, we need to do three simple things. Well, they are not simple, but first one is to create something that is called cloud governance standard and create the landing zone for our cloud platform infrastructure that will provide us the ability to easily deploy, maintain, and develop of our application. Second one, we need to implement a DevOps methodology which will transform the way that we create the software, the way that we maintain it, and at the end, we need to adopt some cloud native architecture standard. So let's talk about all of these three. Let's start from the cloud governance and the landing zone. So at the beginning, before we start to deploy our solutions to the cloud, we need to create this our basic, let's call it environment. Because, as you know, in cloud, we pay almost for everything that we use. So if we do something wrong, then we can pay a couple times for the same functionality. We can, for example, lose some of our resources, and after 1 or 2 years using the cloud, someone will discover them and said, who is the owner of these resources? For what? It is here. We are paying for it for the last 2-3 years. And etc. And to do this, we have to start from the resource governance. We need to create the resource hierarchy, naming convention, tagging, and the policies. And this is the first thing that we need to address to create our solution and create a roadmap for migration of our on-prem application or new application to the cloud. Second one is identity. So how our identity will look like. Yeah, we are speaking about the hybrid identity, how the accounts will be managed, what roles we will create, what privileged identities we will have inside the cloud, and the service account, which provide the ability for a specific application to communicate with others, to communicate with the cloud APIs, etc. This all needs to be standardized and need to be implemented in the infrastructure as a code methodology. Next thing is networking. And this is very important. And many people, especially in software development, forgetting about this one thing. Because, when you create a software in on-premises environments, you do not care about the network. It's the IT guys. They are responsible for it. In cloud, it looks a little bit different because, well, first of all, if you are not working in the small startup, you always will have to handle the hybrid cloud scenario because every organization already have some systems on their on-premises data center. And even if their goal is to migrate only to the cloud, the first 4 or 5 years, it always will be the hybrid cloud. You can't just take all on-prem system and migrate to the cloud in one day. It's required time. And to do this, there are many of challenges that we need to address on the level of, let's call it architecture, and the way that our application works. Because, for example, let's say this example of our customer from the financial sector. In the financial sector, you can't, for example, send the data via public internet. So that means that all your services need to communicate between each other in private network inside the cloud and through the hybrid infrastructure, VPN, or dedicated, for example, connection for every cloud provider has one. And to do this, if you are using the PaaS solution, in almost all of the clouds, the PaaS solutions are the public available. So the main data transfer to these services is through the public internet. So in this case, you have to modify them, adding some kind of the, let's call it, extra features for transferring the data inside the private network. And you need to pay for it. You need to pay for the data that are transferred through this, let's call it private links, private endpoints. And you need to know this at the moment when you are creating the architecture of your application and consider it as a cost of your solution. Because based on it, you can modify some, let's call it architecture or even the code level functionalities. And to do this, you need to address the networking and you need to create the network architecture. Also, there are some components that are common for the different applications because when we are speaking about large companies, we have more than one system, more than one application. And in this case, for example, we have a couple applications that will want to communicate to our on-premises system, etc. And in cloud, we pay for everything, so every hybrid connectivity will increase our cost, total cost of ownership of our, let's call it cloud solution. So we need to somehow take one hybrid connection and share it between different applications. And for this kind of the work is our landing zone, our main landing environment on which we will put our application. Next thing is the security and monitoring. So for example, data encryption, what we will do with logs, telemetry, container security, etc. Then we go to the infrastructure. So we need to know which compute resources we're going to use inside our companies, in which localization, how the disaster recovery will look like, how the high availability, scaling, etc. The data governance, because all systems in the cloud are the big data systems, cost management, and automation. And before we start really to concentrate on our application, we need to address all of these things. And this is really simple example of such landing zone. In the real case scenario, it is much more complicated, but this is the part of this first element of our cloud native application, this interoperability, infrastructure softwareization in infrastructure as code model, automation platform, and migration. And this is the baseline for creating our cloud native application. Then, after we address this thing, we can go further and concentrate on the cloud native application. And here from, let's call it this architectural and development perspective, are 12 rules that you need to follow to create such a solution. I know that many of you know these things because this is the 12-up factor. There are many different variations of this, for example, beyond 12-up factor, etc. But for those one who do not know it, I will just very quickly go through all of these elements. First one is the code base. In modern day application development, it's very, well, this is the standard for today. We have one code base for every application, and from this we have many deployments of the specific application. To do this, we need to address our dependencies. So everything that our application required to work need to be somehow installed in the automatic way. So here we are speaking about our dependency managers. We are speaking about declarative approach to create the containers where all features that are required by our application can be installed by in automatical way, because in the best scenario, every environment, starting from the test to the stage pre-production, production environment, will be deployed and managed in an automatical way. So no one should touch them directly, and the whole processes, whole automation stuff, etc., should be done by the machine. Next one is configuration, and this is very important. So we have to create the separation of the configuration and the secrets from the code. So if we have our application and we, for example, deploy this application on the production, test, stage, etc., the only difference between this application is the configuration. So we have the same artifacts that we put on the different, let's call it, environments, but the separation of the configuration and the secrets provide us the ability to deploy it in such, let's call it, way with a small technological time and the time gap. The next thing is the backing services. So we need to have some services that will, for example, be used by our application, where we can put the state of the application. Here we are talking about MySQL database, for example, NoSQL database, queues, etc., mem caches. And this is also a very tricky part, because in the standard approach for cloud-native application, we will try to use the PaaS solution inside the cloud. But the problem is when you are dealing not with, for example, 10 application, 100, but for example, 10,000. And we have one of our customers, which is one of the biggest enterprise in the US, have more than 10,000 different services. And in this case, using this backing services in the PaaS model, so for example, the database, the storages, the queues managed by the cloud, was a real challenge. So they figure out that, okay, so what will happen if we treat the backing services same as the cloud-native application and put them in this model, so put it inside the containers and, well, create this all CI/CD and DevOps methodology for it, and then just connect the storages as a backing up services for a backing services, and store the state inside it, but the whole magic will be inside the containerized, so cloud-native backing services. And this is also a good approach, because when you are, for example, going through some scale, using a PaaS services inside the cloud could be a problematic. So you need also some standardization and the approach then to handle the backing services. But at this moment, let's put it that we need a backing services where we will put a state of our application. After that, of course, we need to create this build, release, run. So this is the really easy pipeline. I think that everyone knows that, so I will skip it. The fun part is the processes. So our application need to be developed as the stateless processes that will be able to scale out in our environments. And to do this, our processes need to be isolated and they need to be totally independent. So you can't, for example, share something between these processes, because then you will not be able to scale out these applications, services in the proper way. Okay, next thing is the port binding. So, you know, in cloud native approach, all application should have its own port, and the port addressing should be the part of, let's call it, addressing the communication between the services. Next, we have the concurrency. And this is the very also important thing, as I said, because here we try to scale out our application. So we do not increase the number of the resource for a specific application. For example, if there is a bigger workload, we create another instance of our application, and then another, and load balance the traffic through many instances of our application. And this provides us the ability to use this scalability benefits of a cloud. And this is one of the most important thing. Also the separation. So for example, we try to separate the application which are, for example, doing different things to the different processes. So when we, for example, have one application that have the REST API and also need to process the data in the background, so we try to separate on the two different processes, two different applications. One which will process the data in the background, and one which will receive this data and will be our, let's call it, web application. Another very, well, everything is very important, is disposability. So here, in Cloud Native Standard, we are working on this one very important conception. Our application will scale out dynamically, and they will scale down dynamically, and our, let's call it, orchestration mechanism will be able to take our process, well, kill it on one of the machine, and, for example, put it on the another. And to do this, our application needs to shut down gracefully, and also need to start and end the life cycle very quickly. Because when we are talking, for example, about 100, 200 services, if every of them will launch in, I don't know, 15 seconds, then in the pessimistic scenario, where there will be some failover of, for example, a couple of the nodes or infrastructure in the cloud, when we sum up this 10 seconds for every service before they will be ready, it will be a couple of minutes of downtime of our environment. And this very quickly, it's called startup and shutdown of our application is important. Another thing, so for example, if we are using our cloud environments, we have something that is called, for example, spot instances or low priority machines, which are 10 times cheaper, for example, than the normal machines. But there is one tricky part. So our vendor can shut down this machine at any time where the resource consumption in the specific region will be too big, for example, or there will be no free compute power there. And to use this, our application has to shut down gracefully, because they will have this signal for terminate, and they have only 60 seconds to save their state and to shut down. After that, the whole node goes down. Okay, next one is the development production parity. So as you know, we need to have this environments as close as possible. We have our logs, which also need to be treated as a specific event stream, and all application need just to put it to the standard output, and on the platform level, we will address how to manage that. We have the admin processes that we need to take care and use it as in the same way as our application. So they need to be deployed as the processes that run on the every single environment and are automatically propagated between the environments. So this is the basics. Okay, let's go for our hero. Our time is short, so what next for our hero? Well, we start our work with our cloud governance and landing zone. Then we create the simple app assessment that I will talk about. And we qualified some of the application to be migrated to the cloud. Because not all of the application should work in the cloud and can work on the cloud, but those who can You can transfer in the two different ways, lift and shift, so you are taking the application as it is and launch in the cloud, or re-platform, so change the physical architecture and the way that application work inside the cloud. And to do this, we have this, let's call it, we create our different levels of app cloud maturity, start to cloud tolerant, ending on the cloud native, where the first one is just lift and shift with infrastructure automation, and the cloud native is the application that can, let's call it, perform all the tasks in the cloud. Well, I will not be talking about cloud ready and cloud optimized because I will need to end. Okay, so inside the cloud native principles, we create a very simple matrix that standardizes the processes and the way that our application will be built. So, for example, we start from the APIs and the communication between services. So every communication need to be standardized in the very specific way. We need to somehow organize the dependency. We need to split this config and secret separation from the code for a specific environment. We need to address our process, discovery and port bindings, observability, and the API aggregation, which is very important because we have a lot of different services. We need to create a bounded context where we have one context with one data model for the specific services, and we do not have this, let's call it, cross communication between that one service goes to the database of the another, etc. So, and we need to have a specific separation between the front and the back ends, and create, for example, in this a little bit of N-tier application architecture, specific sub-networks, specific sub-infrastructure that will provide the ability to host the front-end application with the access to the public internet, for example. And we need to implement the security best practices and also determine what kind of technology we want to allow to use by our software developers, because in this microservice world, everyone could choose whatever he wants. So from the organization perspective, we need to take care of it. And last one, we need to create the health and liveness checks so our application can communicate with the platform that they're working and they are able to handle the traffic. And based on it, we can approach the replatforming. And this is the very easy way. So we start from here and we end there. And our goal is to create at the beginning every new feature as a microservice. And then after that, with the time, migrate our monolith application to the microservices architecture and put it inside the cloud. And there is also another thing, so new application. Here we approached with a little bit of domain-driven architecture, where we plan our resiliency, load balancing, distributed tracing, service versioning. We create the API and the communication standard between the services and between the domains, because every domain should also be separated on the logical and the infrastructure level and communicate between themselves only on the very specific, let's call it, protocols and the way. Okay, so to address all of these challenges, we use service mesh, Istio-based, which provide us the ability to load balance on the session level, level 7 routing based, retry or failed request, it's implement retry policies, implement the circuit breaking pattern, and also it can capture the metrics about the communication inside the clusters. And very important thing, it also provides us to safely communicate between the service, because in the financial market, there's the requirement for encryption at transmit, and in the cloud native architecture, we need to address this challenge by our own. Okay, also we need to standardize the backing services. Our time's end, so I will maybe skip this part. Treat the logs and telemetric data as a stream and use the data engineering practices for it. So you need to create the pipelines that will proceed and work on your data, for example, somehow check for the anomalies, exec the no-ops automation that will somehow influence the physical cloud infrastructure, the services by itself. And at the end, you need, on the organization level, to implement DevOps methodology that will increase on every single level the ability to easily create and deliver your software to the customer. Okay. Questions, or we are skipping this? Because we are 5 minutes after the time. Oops, sorry.